All right, everybody, welcome here to lesson number 8, more advanced similar triangle proofs. So in class, we did most of this lesson, but I figured I'd make a video here that goes over the whole lesson from the beginning. So if you feel like you got a good grasp on what's going on, you can just fast forward to the point of the video where the homework starts or wherever we finished in class. So the first thing here in the opening exercise, it tells us that we have two sets of parallel sides. So we know that AB is parallel to DE. Well, if that's the case, we're going to have alternate interior angles. It's like angle 1 and angle 2, angle 3, and angle 4. They're going to be alternate interior. So I know angle 1 is congruent to angle 2, angle 3 is congruent to angle 4. If you label them differently, no big deal. I also know that we have vertical angles right here in the middle, which I'll call angle 5 and angle 6. So I could say those are congruent as well, just by a different reason. Now, this is not a proof, so I'm not asking you to write the reasons down. Totally could be, but it's not. So then it says which two triangles are similar. So this is really just testing, you know, that if I label triangle ABC, whoops. If I label triangle ABC, and say that it's similar to the other triangle, I got to label the angles in order of their corresponding. So D and A correspond, so I'll put D first. E and B correspond, so I'll put E second. And then C corresponds to itself. And the reason why is because of all of the angles being congruent, which we just call angle. If the two triangles are similar, what do you know about their lengths of sides? I know that the corresponding sides are proportional. Now, what this means when I say the corresponding sides are proportional is I could set them up in a proportion. So here's a proportion, and notice I've cross-multiplied the proportion to get a product, or what we call a cross product. So a product of two items is equal to a product of two other items. I'm getting this just by cross-multiplying. Now in math, we don't say cross-multiplying. That's not really the valid way of saying it. We say the product of the means is equal to the product of the extremes. So if this was a proof, and I asked you to find that the segments were proportional to each other, I could just say in similar triangles, the sides are proportional. Then if I was to actually cross-multiply this and find the cross product, I can then say the reason why the cross product is valid is the product of the means equals the product of the extremes. Now, you might be saying that this feels similar to what we did with the congruent triangle proofs, and it is. It's very similar to CP-CTC proofs. Not exactly the same, but very similar. So let's take a look at an example. So as soon as I see this, I see a cross product, all right? I know I'm going to multiply EC and AD together. So when I make my proportion, if EC is here, AD must be down here. Then I have to figure out, well, what matches? EC matches AC. So then I got to put AC wherever EC was and EB away from it. So I'm winding up creating a valid proportion. So in this proof, it tells us that angle EBC is congruent to angle ADC. And that's given. Because that's given, I can put it right into my proof. So I'm going to be able to say angle EBC is congruent to angle ADC, and that's given. Now, to prove these two triangles are similar, I have to also find another angle. Lucky for us, angle C is in both triangles. So I could say angle C is congruent to angle C by the reflexive property. Now, that's enough for me to say that these two triangles are similar. I just have to name them correctly. So I'm going to say triangle ADC is similar to, now I used angle A first, so I got to use angle E first because they would correspond to each other. Notice how they're labeled. EDC by angle. Now because of that, I now know that EC over EB is equal to AC over AD, the proportion that I was able to undo the multiplication for. And I know that that's true because in similar triangles, the sides are proportional. And because I know that, I can then say EC times AD is equal to AC times EB, exactly what it asked me to prove, because the product helps us spell product, right? Of the means is equal to the product of the extremes. Long sentence, but it's the same every single time. Now, if you understood that proof, that's probably going to be similar to what I would give you on your test for this chapter. Let's keep going. Let's take a look at another one. Number 2. So again, we're looking for angles. If we know we have congruent angles, we know I have similar triangles. So again, I know that MN has to be multiplied by MR. MN and MQ match, so I got to make MQ across from MN. So I make a valid proportion. That's the proportion I'm going to try and use in my proof. But before I could get there, I have to first show these two triangles are similar to each other. Now it does tell me that NP and QR are parallel, meaning I'm going to have these corresponding angles. I also see angle M is in both again, so I have the reflexive property. I even could say angle P and angle R are the same if I wanted to. All right, so I could actually do this proof a couple different ways. So let's start by saying NP is parallel to QR. That's given, because I need that for sure. And that's going to tell me that angle Q is congruent to angle 1 because of corresponding angles. I also know that angle M is equal to itself. That's the reflexive property. And then I could say the two triangles are similar. So I could say triangle M and P similar to triangle MQR by angle. Now, because I know that, we can then say that the segments are proportional that we figured out by unmultiplying out the cross product. And we could say in similar triangles, the sides are proportional. Okay, you notice these last two steps are exactly the same as what we did in the last problem. So now that I know that the sides are proportional, I can then say that my segments are going to be multiplied out. So I could do my cross product here now. So now I could say that MN So now I can say MN times MP is the same thing as MQ times MP. No, I have that wrong. Let's see what I wrote down wrong. That should have been an R. And we could say that's because the product of the means equals the product of the extremes. Sorry about my handwriting. It's not great tonight. All right, so let's keep going. So next one is kind of like a challenging question, right? Same idea. So I'm trying to figure out a proportion of QM times UR and WT times UV. But before I can get there, I first say that these two triangles that involve those segments are similar to each other. So UV is here, and I'm going to use some color here that might help. So UV is here. UR is here. So I'm probably going to use that triangle. QW is here. And WT is here. So I'm probably going to use this triangle. So it tells me that this is a rhombus. So what do I know about a rhombus? I know the right angles are going to be here. So I know that angle, which I'm going to call angle 1, is a right angle. I also know that the diagonals bisect each other. So I also know that this angle and this angle are congruent. And because of what it says here, perpendicular, I know this angle is also a right angle. So that should be enough information for me to prove those two triangles are similar. Now, this proof is just going to involve a little bit more work because I'm using the fact that it's a rhombus. So the first thing I'm going to say here is UV is perpendicular to QR. That's given. That's going to tell me angle 4 is right. Because perpendicular lines form right angles. Now, that's not saying anything's congruent. It just tells me it's a right angle. I also know that QRST is a rhombus. That's given. Now, that given is going to tell me two pieces of info. It's going to tell me angle 1 is a right angle. So again, this tells me angle 1 is right because in a rhombus, the diagonals are perpendicular. Now, if I have two right angles, I know they're congruent to each other. So I could say angle 1 is congruent to angle 4 because all right angles are congruent. Now, I also know because this is a rhombus that angle 2 is congruent to angle 4 because in a rhombus, diagonals bisect each vertex. Now, you don't have to say it exactly like that. If you said like the diagonals bisect each angle, I'd probably accept that. But the real name for those corner angles is the vertex angle. So now that gives me enough information because I have two congruent angles. Tell me that triangle QWT, the right triangle, is similar to triangle VUR by angle. Now, because of that, I can now say that my proportions are valid. So QW and UV is equal to WT over UR. Make sure I don't make a mistake that time. And we could say in similar triangles, the sides are proportional. And because I know that, I can then say that QW times UR is equal to WT times UV, because the product of the means equals the product of extremes. There's your proof. Now, that's what I was hoping to get to in class. I know in class we probably did not get to this example, right? But that's a really good example if you think about it. It's really testing on everything we have to do for proofs. That's a good Regents question. So let's take a look at the homework. Homework is just one question, so nice and easy, all right? So again, it's asking us about this cross product. So let's figure out what the cross product is first. So if we undo the cross product, I know these two things on the left-hand side are going to multiply together. They got to be across from each other, meaning DE and EA also have to be across from each other. It tells us straight up that angle B is congruent to angle D. So I could put that right into my proof. I like that. Nice, easy given. And in looking at my picture, I also see vertical angles. I'm going to call this angle 1 and angle 2. So I could say angle 1 is congruent to angle 2 by vertical angles. Then I could say the two triangles are similar. So I could say triangle ABE is similar to triangle CD by angle A. Then I know that my cross product undone, so my proportion is true. So BE over EA is equal to DE over EC, because in similar triangles, the sides are proportional. And if I know the sides are proportional, I know my cross product is going to be true. So BE times EC is equal to DE times EA. And the reason why I know those are true is because the product of the means equals the product of the extremes. That's it. Hopefully this video helps. All right, if you need to, remember you could always rewatch the videos before your test coming up, because we only have one lesson left, all right, before your next test on Unit 5. Good luck with your homework. Hopefully you enjoyed the video.